Okay, click and close. I'm going to be super fast here. I want to get, I really do, my top priorities, I want to get you working on this stuff. Let's just make sure we know what to do. And I think we covered enough yesterday that we can do this very quickly. So we talked about evaluating functions, right? So evaluating functions just means that we are plugging values in for x. If I write something in function notation, the f of x is telling us x is the input and the output is f of x, right? So if I want to do something like if I want to do g of negative 7, what am I doing? If that's g of x, what's g of negative 7? So there's, if g of x is negative x squared plus 9x minus 1, how do I find g of negative 7? Okay, so every place where I have an x, I'm going to open up a set of parentheses for substituting, right? So I get a minus x squared plus 9 times x minus 1. And in all those places, instead of an x, I'm going to plug in a negative 7, right? And that's just going to give me negative 7 squared is what? 49, and then I've got this negative out front. I'm going to multiply by my 49, so I get a negative 49. 9 times negative 7 is negative 63 minus 1. So what's that give me? 64, so I'm going to get 113, is that right? Negative 113. Okay, right? So that's telling me then, if I write this as an ordered pair, what's my input value? What did I input? Negative 7. What was the output? Negative 113. Good, so if I wrote that as an ordered pair then, I get that one. Okay. If I do something like I'm going to multiply 2 times g of 12, just remember, if I have f of negative 0.4 or g of 12, anytime I'm plugging a number into a function, I'm getting back a number, getting back an output number. So when we see g of 12, we're thinking, okay, I know that's going to be some number. When I put 12 into the function, I'm going to get back some number that I'm then just going to multiply by 2, right? Okay, and if I do if I want to do something, even more complicated like f of 1 minus f of 4, well, big deal. That's just going to be whatever number I get, the output number for 1 for the function f, minus whatever the output number for negative 4 is. Now, where people are going to make a mistake on that, I'm telling you right now, you're likely to make a mistake here. If I do this, I've got, let's color code this. What's f of 1? Negative 5 times, instead of an x, I've got a 1, right? Minus 14 minus f of negative 4. But what I should do here is I should probably put that in parentheses or brackets, because that all is going to give me one single output number that's f of 1. Agreed? Minus all this stuff right here, f of negative 4 is going to give me one single output number, right? So when I'm calculating what that is, I need to put it all in brackets or parentheses, so I know when I use order of operations that I'm going to simplify all that stuff first before I subtract. That make sense? So that would give me f of negative 4 is going to be negative 5 times negative 4 minus 14. And so I'm going to get a blue number. Negative 5 minus 14 is a blue number, is negative 19 minus a red number. Positive 20 minus 14 is 6. So negative 19 minus 6 is my total answer, which is negative 25, right? Okay, and then we looked at what happens if we, I guess this is where we left off. So what about something like this? This is slightly different now. This time they're saying something like, if f of x equals 34, find x. That's different. It's not telling you to evaluate f at a number. It's saying the function, the output of the function is equal to 34. What's the input that goes with it, right? X is the input, okay? How would I solve that?
3x
Equals 34. Exactly, right? I'm plugging 34 in for f of x. Right, 34 is what's getting plugged in for f of x, and so I get the equation 34 equals 3x plus 19, and then I just solve for x. That's easy though, right? Just subtract 19 and divide by 3. So if I divide by 3, 3x equals 15. So I know that when the output is 34, the input had to have been 5. Okay? A little different. I can do that with technology. It makes it really simple. So this is a great trick. We're going to do this all year. From this point forward, you're going to like this. Every unit test, or almost every unit test, is going to have a part of the test is going to be a graphing utility part where you get to just use Desmos to do the work for you. And they're really simple if you just know how to use Desmos. So here's how we could use Desmos in this situation. I'm going to use the graphing calculator this time, not the non-graphing, not the scientific. And I'm going to put in the function. Right, so there's my function, f of x equals 3x plus 19, and it gives me a graph, right? And then I want to know where is the output of that function equal to negative 62, okay? So I'm going to graph, what do you think I'm going to graph next?
F of x equals negative 62.
Okay, but instead of f of x, I already defined f of x as negative 3x plus 19, but you're on the right track. I'm just going to call it y, right? Because the output is a y value, isn't it? Right, so if I graph y equals negative 62, look what I get. If I zoom in a whole bunch, I get something like that. Now I get this horizontal line. That's what that is though, isn't it? If I graph the line y equals negative 62, it's just a horizontal line where the y value of each point is always negative 62. And what am I going to do with those two graphs, do you suppose? See where they intersect. So on Desmos, if I click on either one of them, it's going to make a little gray dot there. If I click on it, it gives me the coordinates of the point of intersection. Let me scoot this up a little bit. I'm going to take a picture of that. Okay, so what did we do? All we had to do was whenever I want to solve an equation by graphing, I'm going to graph the left side of the equation, I'm going to graph the right side of the equation and see where they cross. Every time that's going to work. Right? So when I graph the left side, f of x equals 3x plus 19, I got the green line. Graph the right side, I'm graphing y equals negative 62, I get the purple line. And so the solution is find x. The solution is x equals negative 27, right? Because that's the x coordinate of the intersection. Algebraically, I would just set the function equal to negative 62 and solve, right? It's not hard algebra, but sometimes it might be in the future, right? And if it's really hard algebra and you can use the Desmos calculator, you don't have to do it. You can solve it this way, okay? All right. so we know how to do that. What if I ask you to do something crazy like this? What if I ask you to evaluate a function at some place that's not a number, like c plus 2? The same rules hold, right? If f of x is negative 4x plus 9, then f of 5 would be negative 4 times 5 plus 9. F of negative a million would be negative 4 times negative a million plus 9. F of a would be negative 4a plus 9. F of c plus 2, the quantity c plus 2, all I'm going to do is where I used to have an x, I'm just plugging in a c plus 2, right? And see what I get when I do that. If I distribute the negative 4 and collect like terms, that's what I get. So if I write this as an ordered pair, it's going to look a little strange. What's my input? What did I input into the function here? C plus 2. Right? What's my output?
Negative 4c plus 1.
Okay? See how that works? Okay. All right, last issue. I'll let you work. So what about, the reason we use functions is to solve real world problems, right? Like I think the example I talked about the other day was like if we had a cannon set up at 45 degrees and we're shooting cannonballs out of this thing. The only thing I could do to impact how far the cannonballs are going to go, because I can't tilt the cannon, we're going to have it just set at 45 degrees the whole time. The only thing I could do is make the cannonballs come out faster or slower to control how far down range they go, right? So I would come up with some kind of a crazy function. I would say something like maybe d for distance, like d of v. So distance as a function of velocity, right? So as I change the velocity of the cannon, I should be able to predict, if I have a function, I should be able to plug that value of v into my function and figure out what it predicts for the distance, right? That's what we do in the real world with math a lot of times. So here's just another little example. Owen paid a landscaping company $108 for an initial lawn treatment, then $74 per month thereafter. So here's the function that helps us out. P of t equals 108 plus 74t. Represents the total amount of money he will have paid after t months. So what are we inputting into this function? Here's the function. What are we inputting? Okay, but I mean just in general, if it's P of t, what's the input variable? T. Okay, so I'm inputting t, right? What does t stand for? Number of months. So I'm inputting a number of months, and what's it outputting? Well, the function represents the total amount of money he will have paid. So I guess P stands for payment or something, right? So P of t is the output, and that's telling us how much he's paid when I input a certain number of months, right? So P of 24, what's P of 24? How would I find P of 24?
Equals 108 plus 74.
Okay, which is going to be, if we do the math, oh my goodness, what's that going to be? 1, 6, 9, 6, is that right? So I get, is that right? So I get, can't do it. No, sorry, it's going to be 1, 7.
1,796.
1796, is that right? Is that what that is?
1776.
177, okay. So I get 1,884 for my total. Okay, so then what's that tell me? What's my input then? For this one. What number did I input? 24. What number did I output? What's that telling me? There you go. Okay, after 24 months, that's how much he's paid, right? Okay, no big deal. How would I do this one then? What if this bottom one here, what if it says he's been receiving lawn service for some time that we don't know, but he's paid a total of $29.94? We wanna know how long.
Solid.
Yeah, this time, what am I input, is that an input or an output?
Say,
Output.
It's an output, right? Okay, we wanna find the input, T, don't we? Yeah. Okay, so that's the output this time. That's gonna be the value of the function. That's P of T, isn't it? Right? And we wanna know what's T. Yep.
Sorry, can I go to that graph?
Yes, you may, you bet. Okay, so here's our function, P of T. We're gonna set P of T equal to 29.94, and that equals 108 plus 74 T, right? This is an output number, and I'll just solve for T to find out the value of T that goes with that. Okay, and you can do that, subtract 108 and divide by 74, right? If I wanted to graph this thing, I could, in Desmos, I could define that function, P of T equals 108 plus 74T, it's gonna give me some line. I could put in Y equals what? 29.94, right? There's the output. And look for the point of intersection, and the X coordinate is gonna give me the value of the input, right? Think you got it? Okay, that was quick, huh? I'm done. So do the E-ticket first. The E-ticket is, it's the 2.2 E-ticket 1.